Welcome back again to our class. So in today's class, we are talking about process description and control. Process description as well as the control. So let's dive into it. So the process within the operating system. So remember the previous chapter was operating system. We spoke of what is an operating system is. So this time we are talking of the process. The process within the operating system, this is something that is currently under execution. Okay, so an active program can be called a process. So a process is basically what the CPU is, the CPU or the program that is currently running. That is a process. Okay, so the execution of the process must progress in a sequential fashion. When the program is loaded onto the memory and it becomes a process, it can be divided into 4 sessions. So I want to show you what I'm talking about. Okay, so let me show you what I'm talking about. Okay, so we need to go to the task manager. So just look for task. So here's task manager. So within the task manager, you find all the processes that are currently running on this computer. Okay, so let me show you. You see this under here? These are processes. These are all the programs that are currently running. And it will definitely tell you the back. Let me just even make it a little bigger. So these are all the processes that are currently running. Okay, and you see, they will also tell you the total process utilizing across all the core, meaning all the CPU. And of course, this is now the physical memory used by the active processes. And it will also tell you the physical drive, the hard drive, and of course the network. Then we come to the GPU and many, many more. Okay, so these are the programs that are currently running, and these are what are called processes. Okay, so if we go now to the services, these are services currently running, and you can see they have status. I mean, the status of it, and it will also give you the service the process ID. It will tell you the description. Also, you come to the details of all the processes that are currently running. Okay, so these are the details about the ID, the status, as well as the username and the CPU allocation and the memory. So this is what is currently going on. So these are the processes that this this computer is currently having. I hope that make much better sense. So let's get back to describing now this process. Okay, so they are saying that when the program is loaded onto the memory, it becomes the process. You saw that all the programs that are currently running on my computer, they are shown on the task manager. So as soon as they go to the memory, and remember, the memory keeps programs that are currently active. Okay, so that is what they do. Good. So it says that when the program is loaded into the memory and it becomes the process, it can be divided into 4 sessions. Okay, so now let's look at the status of the process. A process is always in a state. Okay, so it's like, what state is that process? So the first state is new. And when it's new, it basically means that this process has been created. Okay, the moment you open it, meaning you have created it. but has not been admitted into the pool of executable processes. It has been open, but it's not yet being in the process of being executable. The process can also be ready. You will find the process that is ready. Okay, processes that are prepared to run if given an opportunity. Okay, so that is, they are not waiting on anything except the execution. So from it being created, then it goes in the ready state before it goes into the running state. So now when it's in the running state, that means it's being executed. So when it's being executed, so meaning the processor is working on it. It's not just in the memory, it is being worked on. And before it can be, it can also be blocked. This processor can be blocked. A process that can't execute until a specific event, such as an input output completion. So suppose something happens to that execution. So it can't execute, it can't continue until an interference of input and output. So that particular process needs to be on hold. And it's not in the ready state where it's waiting to be executed. It was being executed, but then it cannot be executed before an input or an output interferes. So that means that one is just blocked. And then we have now the exit. A process that has been released by the operating system, either after normal termination or after abnormal termination when there is an error. As long as the CPU have released it, or the operating system have released it, have terminated it, that means it has finally exit. So these are the 4 status, 5 status a processor can be in or can be found in. Is either new, ready, running, blocked, or exit. Okay, so this is a diagram that shows, now will show to you is how status transition the diagram. How does it transit? So when it's created, this is how it created, then it becomes new. So when it's new, it needs to be admitted. As soon as it's admitted, then it comes to be ready. Being ready means that it's waiting to run. So when it's waiting to run, it can now be run, which is execution, and then it can be released. Okay. Alternatively, you find a process can be created and it can be admitted, then it will be ready. But when it's ready, it can actually go back to running, and then they can take it back again, especially when the time is out. When the time is out, then that process will be sent back to a ready state before it can be run again, and then it can exit. Or you find this particular process, it was ready enough, but then, and it was also running, but because it's waiting for an event, then it needs to be blocked. As soon as it's blocked, and as soon as that event from the input or an output had occurred, then it needs to go back to a ready state. After a ready state, then it can be run, then it can be released. So this is just a diagram that is showing you how the states are working within the operating system. Right. So the next thing is that the process description. So operating system maintain the data structure, which keeps track of complete information about each process. It keeps the complete information. Let me show you again what I'm talking about, the description and keeping the track of a complete information about each process. Let's go back to taskbar again, okay? So this is, the task manager. This is the task manager, okay? And these are the processes that are currently running. So if we come to the details here, you could see, and these are the status that I was talking about. You see, like this one has been suspended and this one is still running, or these ones are still running. Okay, so these are the details, such as the process ID is a detail, the name is a detail, the username is a detail, the CPU it's occupying or the core it's occupying is a detail, as well as the amount of memory. Those are description that the operating system keeps about that particular process. Okay, so that is what it means by process description. It's basically what it describes the process. It's like you yourself, you have your own description, your name, your ID, where you are working, which is actually the status, either you are working, you are a student, you are married, not married. It's a description about you. Also, the process have their own description. Okay, and this data structure is the one that is called process control block. Okay, now the process control block keeps information needed to keep track of a process. Okay, so the architecture of the PCB is completely dependent on the operating system. Each operating system decides which kind of information they keep on that particular process. So you may find that other operating system, they keep different kind of information for that particular process, differ to another operating system. The kind of information then that is kept on the process control blocks are such as, you have the process state, you have the program counter, you have the CPU register, you have the CPU scheduler, you have the input and output status of information, memory management, accounting information, other information that are not here, like what we saw, there's process ID, there is a name and all that. Those are information that describe that particular process. Okay, so I hope that is clear. Okay, so then we come to operating system execution. So with the operating system execution, the process of execution, the operating system on the CPU is called operating system execution. The process when this operating system is being executed on the CPU, it is the same as you saying operating system execution. So the operating system execution, it happens when there is no other programs to execute. When the other programs are not yet opened, then the operating system what? Execute. Now the operating system is the program that a computer execute when first started. So as soon as you open your computer like this, the operating system is executed first before any other program is executed. Remember, like what we were saying, that the operating system is an interface between the hardware and the software. So that's why then it becomes the first program to be executed. Okay? So the next one is the Unix process management. How does Unix manage its processes? It's because of this guy here who is called Unix kernel. Remember, Unix deals with a multi-user as well as a multi-core operating system. Multi-user means that this particular operating system, this particular operating system, it handles a lot of users and it does a lot of work. This processor can actually execute as many processors as it can. That's why it's a multi-processing. And the multi-user, it allows users to work on it. Processors means it can execute a lot of executions. Okay, so that is what? Multi-processing. And kernel handle all this multi-processing and multi-users. So, and as well as the time sharing. There might be 100 over 1,000 of processors running, and each user on that system have several activities processes. at once. So that is how Unix manage its processors because of the Unix kernel. They handle multi-processors, multi-users, so it allows it to process as many as processors as it can be. So on that note, that brings us to the end of our information, and that's where we took the information within this slide. Thank you so very much. So I'll meet you in class until next time. Bye.